Year 7 sound knowledge test. So all the facts and all the bits of information that you're going to need to pass the knowledge test on the sound. Right. So label a longitudinal wave. So what we've got here is we've got a compression. All right. So this is then with the wave where all the particles are well and truly squashed together. Here, I'm going to write it in the box, is a rarefaction. That is where there's not as many particles. Okay, they're kind of dotted around. From the center of a compression to the center of a compression is a wavelength. Okay, you can also have it from the center of a rarefaction to the center of the next rarefaction over. Okay, so describe the difference between a light wave and a longitudinal wave. So a light wave is a bit like that, you know, the one that we did before. A longitudinal wave is where I always draw them close together and then narrow and then wider and then narrow. Now these little lines here, they should be the same length, but they're your compressions, but they're then closer together. Now the main difference is the oscillations. Right? In a transverse wave, the oscillations are perpendicular, which means that they go up and down like that. And the oscillations in a transverse wave are parallel. Right? That means they're going backwards and forwards like that. So that's then the particles. What is the speeds of sound in air, water and steel? Air, water and steel. So air is 340 meters per second. Water is 1,500 meters per second. And steel is 6,000 meters per second. So that basically means that in air, if I make a noise, it will travel 340 meters in 1 second, okay, which is a fair distance. Water and then steel is obviously even more, and it's all to do with how dense the particles are. Describe a method for calculating the speed of sound in air. All right, now this is a terrible method, right? It's not very accurate at all, right? But what you got is you got two people. Okay, these people then are 200 meters apart, right? So they'll probably barely be able to actually see each other. This person here has got a stop clock. Okay, and the way that it then works is this person here makes a noise. Okay, whether they clap or whether they bang something together. He then starts the stop clock when he sees the person make the noise, because light travels much, much quicker. Then what he does, he then stops it when he hears it. Okay, and that amount of time then is theoretically how long it's taken to go from one person to the other. Then you use the equation, speed equals distance divided by time. And if the distance is 200 meters and the time took 2 seconds, 200 divided by 2, right, is then 100 meters per second. So theoretically, okay, so what is the frequency range of human hearing? This is then just a fact to learn. It's 20 to 20,000 hertz. Right, the ear. Right, now the ear is dead important, right, because obviously it's got two jobs really. The obvious one is hearing, right, but the less obvious one is balance. Right, so what we're going to do is you can start here and we're going to call this the cochlea. Okay, it looks a bit like a snail shell. Then here we've got the eardrum. Okay, so the eardrum, so that's like a very, very thin piece of skin right at the end of your ear. I think that is then supposed to just be the ear. Here we've got, I'm going to start writing out of the box, ear canal, right, which is to put your finger in, right, but obviously you don't put anything sharper than your finger in. Here is the pinna, okay, that's the floppy bit on the outside of your ear. Then what we've got is we've got 3 bones in the middle, and it goes hammer, anvil, stirrup. And I'm going to write them up here. Hammer, anvil, stirrup. Okay, whoops, right? And what they do is they kind of look like it, particularly the stirrup. And these are the small bones in your ear. And what they do is they transfer information from the eardrum into the cochlea, which is this here. And that yellow bit coming out there, I'm going to do it in yellow as well, right, is the auditory nerve. Okay, which then takes the information from your ears, right, to the rest of it. Now, your cochlea, right, and it's a fact, I'll just mention it now, those three little kind of loops there is also your balance, right, which is dead cool. Right, keywords. The range of frequencies you can hear is the audible range. A commonly used unit of sound intensity or loudness is decibels. The reflection of sound wave by an object is an echo. The unit of frequency, hertz. The material that affects light or sound by slowing it down or transferring the wave is the medium, what it's travelling through. And then the small bones in the middle ear, the hammer, the anvil and the stirrup that transfer is the ossicles. Okay, I call them small bones on the previous diagram, but a better word is ossicles. Okay, again, facts, right? Facts, learn, repeat. Okay, so make sure what you're doing all the time is you're going through it, you're learning it, and then you're repeating it to make sure that it sticks into your head.